Generator connection accessories, hotspot temperature measurement, hydrogen leak detection, partial discharge identification. Introduction. Generator connections are expected to be extremely reliable. Routine maintenance is carried out during planned shutdown of the unit. However, there is a need to monitor few parameters in critical areas such as hotspot temperature, hydrogen leak, and partial discharge, among others, to undertake preventive maintenance at an appropriate time. Hotspot temperature measurement. In an isolated phase bus, the temperature of the conductor and enclosure will not be the same along the entire length of the connection even under normal operating conditions. Ambient conditions in indoor and outdoor location can be vastly different. The variation is more pronounced with the increase in the rated current of the connection. This can be attributed to the uneven generation and dissipation of heat at various locations of the conductor and enclosure. Aluminium, being a good conductor of heat, will smooth the temperature distribution curve due to the conduction of heat. A well-designed, factory-manufactured sub-assembly, considering the ambient conditions, cannot develop hotspots. A generator connection comprises integrating several sub-assemblies and carrying out significant amount of welding of conductors and enclosures at site. In a conductor, hotspots can develop at joints in the run of the bus or at terminating ends. This can be attributed to several factors including creep, poor ventilation, and enclosure hotspots. Connections near the generator terminals are potential hotspots, mainly due to the poor ventilation and confined area. The forced evacuation of hot air from inside the generator terminal enclosure has been carried out to lower temperatures. Poor quality of site welding of conductors can result in the development of hotspots in that location. Conductor temperature at hotspots can be monitored by installing infrared temperature remote monitoring devices at strategic locations. In an enclosure, hotspots can develop due to poor ventilation, solar radiation, current concentration, such as near bonding bars and bends, improper earthing of terminal boxes at generator and generator transformers, poor site welding, conductor hotspots, among several other reasons. Enclosure hotspot temperature can be identified by infrared measuring devices or heat-sensitive tapes. The temperature of the conductor and enclosure of the isolated phase bus installed outdoors will have to be monitored during midday in summer. Hydrogen leak detection. Most generators use hydrogen as a cooling media. Hydrogen has low density, high specific heat and the highest thermal conductivity of all gases. It is 7 to 10 times better at cooling than air. It makes the heat transfer most efficient. Another advantage of hydrogen is its easy detection by hydrogen sensors. Generators of small capacity use air for cooling. Generators of large capacity use water-cooled conductors. Leakage of hydrogen into generator connections has been observed through the interface of terminal bushings. Hydrogen concentration can increase in the generator terminal boxes over time. Hydrogen, being lighter than air, gets accumulated at the top. Vents are installed at strategic locations on top to facilitate the natural evacuation of hydrogen. Optical gas imaging as well as passive catalytic bead sensing techniques are used in leak detection. Hydrogen leak detection can also be efficiently carried out using carbon dioxide as a tracer gas. Partial discharge identification. In an isolated phase bus, partial discharge can take place wherever the electrical field on the surface of the conductor exceeds the breakdown voltage of the surrounding air. Sharp edges such as on the fixings, laminates, terminals, conductor castings are potential locations. Discharges breaks down oxygen molecule and results in the formation of ozone, which in presence of nitrogen and moisture form nitric acid that can lead to corrosion. It forms a white powder, aluminium oxide coating on the aluminium conductor. It forms a deep blue powder, copper nitride coating on the copper conductor. It can lead to localized erosion on the surface due to incessant bombardment. Discharges in the vicinity of epoxy insulators and bushings can deposit carbon on the surface, thereby reducing the effective creepage distance, resulting in arcing and flashover. Partial discharge also generates a wide spectrum of high-frequency signals of varying amplitude. Online monitoring devices are available for the measurement of partial discharge. It comprises sensors. Typically 80 picofarad capacitor is cast in epoxy, suitable for the specified rated voltage. These will block the power frequency voltage and transmit high-frequency signals. Several sensors can be placed at designated vulnerable locations in the generator connection. Coaxial cable. Each sensor has a coaxial cable to transmit the signal. Sensor junction box. All the coaxial cables from the individual sensors are grouped at one location and connected to a processor by a multi-core cable. Processor. The inputs are digitized, processed, and transmitted to a computer for monitoring. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.